So first of all, thank you everyone for joining the webinar and taking out time from your busy schedule and attending this webinar. So my name is Shubham Shah and I am working as a senior safety engineer at ARK Info Solutions since 2022. And I'm working alongside with the commercial teams, industrial projects supporting various clients in the various domains. So we'll be starting this webinar. The agenda will be seeing how Ansys Engineering Copilot will help you out to increase the productivity, and we will be seeing an overview for Ansys SimAI. So how SimAI can help you out. We'll be seeing a glimpse of that, as well as we'll be seeing how we can use Ansys GPT in our day-to-day life for solving the problems or getting rectified the problems which we are facing during the simulation. When we are doing any kind of simulation, what are the different challenges, or let's say if there are any errors, how we can try to resolve that at our end using Ansys Copilot and Ansys GPT basically. So let's start the webinar. So first of all, we'll be moving towards how what is Ansys Engineering Copilot, how it can be used, where we can find this in the tool. What are the different physics where we can use this kind of simulation in simulation, the Copilot. So basically, the Copilot is your best self-assistant, you can say. It's a reliable and robust virtual assistant, similar to like what we have been using nowadays. Like if we are facing any problems, what according to the trend we do, we go to the Chat GPT, we go to the Cloud AI, or any of the AI tools which we are aware of. We are trying to figure it out from there if we are new to the domain. So generally, how we do is, let's say we have stuck in somewhere. We are trying to do a simulation and we are not getting the results, or let's say we got a certain sort of error which we are not aware of, and you want to try it out and figure it out on your way, like what this error is, how we can rectify, what is the reason for this kind of error. So for that, what we generally do is either we connect to the support team, or let's say if support team is not there, what we generally try to do at our end is we see the open source material. There comes the Copilot and the Ansys GPT. So when we go with the open source materials, we don't have that much of credibility, right? We are not sure whether this is correct or not, or how much we can rely on this open source materials. So when it comes to the credibility, Ansys has launched this engineering Copilot, so which is based upon the entirely Ansys database. So whatever search results you will be seeing, you will be seeing through the entire database of Ansys domain itself, whether it's from the CFD domain, whether it's from the mechanical domain, whether it's optics, or let's say electronics, or Maxwell or electromagnetic domain. So it has a huge set of data which is present. So first of all, you will be having the convenience at your time whenever you are doing it. You can have the access of this AI assistant in the product itself. So you don't have to go somewhere else. You can get the access of this inside your working tool itself. So first I will showcase you 2 3 slides, and then I will take you to the tool directly where you can find this, how we can do perform and utilize this Copilot, engineering Copilot. Then we have the expertise for this, the trained models. Basically, this is based upon the existing Ansys technical knowledge and expertise. So here you will not find any sort of open source data. All the data which you will be getting, all the results or all the answers which you will be getting will be based upon your Ansys database itself. You can also have the learning access. Basically, let's say you are very new to the simulation domain and you want to learn, or you are let's say advanced level of user and you want to expand your working knowledge on certain advanced topics. So that can also be done using this Copilot. And then there is upcoming support from where the answers can you can raise the support directly. So this is an upcoming part. So when it comes to the Copilot, what different things you are having is you can search across all the Ansys website. You have access to 1000 plus Ansys innovation courses, which are free, majorly free. Then you have knowledge articles. A huge amount of knowledge articles are available. Then there is a global form where you can post the queries and you can get reward from the global users, Ansys users basically. Then you can you have the 24/7 virtual assistants along with the tool. So this is the consistent UX. Basically, it's not limited to any of the projects with the tools, the solvers. Basically, you can use it with Ansys Mechanical, use it with Discovery. You can use it with the SCADE one. You can use it with the Fluent. So it is not restricted to only one or two physics. It is open for all the physics. So now I will take you to the tool where we can see how we can open and use and what are the different area ways to utilize this. So basically, let me the this is one of the projects which has already been open. A simple fluid flow problem is there. So this is the Fluent UI basically, the CFD part, and on the top of the ribbon you can see there is a learning and support tab which is already there. So we just have to click over here, and from here if you see Ansys Engineering Copilot is there, Ansys Learning Hub, Fluent tutorials and learning resources are there. Once you click on this Engineering Copilot, you can see on the right hand side Engineering Copilot has been opened up. So this is all inside the tool itself. So once you open it up, you have to log in. So it will ask you for the username and password. Once you enter the username and password, you can have the access for the Copilot. And the major thing is this is not a separate license and it is free of cost. So you can register for this and you can start using the Engineering Copilot and Ansys GPT in your day-to-day work. So once you open this, you can see this is the Search AIS homepage where you can see recommended for you. It will come based upon the tool you are using. So I'm currently using Fluent. So you can see all the Fluid course, Learning Hub, Fluid courses, Innovation Spaces, Fluid, all related to the Fluent, getting started with the PyFluent. So everything related to the Fluent will come in here over the picture in the home. Then you have a learning tab where you can go for the learning. You can search for your learning based upon which physics you want to learn. So this is fluid. So let's say I want to see how to perform the external aerodynamics, right? So once I click, it will pop you up to the new window, and from here you can see this is how you can log in. So I'll just log in.
Shubham, can you please check your internet connection? In between your voice disappears.
Am I audible now properly?
You are audible when you are speaking, sometimes your voice disappears.
Okay, just a second. I will check it up with the microphone settings also. Okay. Now is it properly audible to you all, or you are facing any lag or something like that?
It's perfect. It's perfect now.
Okay. No problem. So as you can see, I have just opened like I want to learn the performance aerodynamic analysis of a car. How can I do it? So once you have seen, you can see you have been enrolled into this one. You can take the different lessons. You can see get the you can go on the YouTube to watch the videos. These videos will be specifically from the ANSYS domain itself and no open source material. It will showcase you. So once you open it up, you can see uh, you will getting the Team Sonic Boom using Ansys Discovery for F1 in school car design. So this is how you can use this Ansys GPT and engineering Copilot. So once again coming back to the tool. So this is for the course. This is for the knowledge. So there are various tabs. You can also bookmark the articles. You want to see the general fluids article. You can search in the knowledge base. Then we have Ansys GPT, the major thing which will help you out to understand the things. So let's say here we have the Ansys GPT and you are solving any of the question problems. of the simple problems or advanced level of problems, and you are facing any issue. So how we can do this? So for this, what I will do is I'll take one of the problems, this simple problem, fluid flow problem, so that we can also see the results quickly, how it is helping out. So I will simply just close this one. I will do the meshing and everything here itself. So the problem is very small, so it won't take that much amount of time also to run this basically. So what we will do is we will just simply do the shared topology, and we will do some pre-processing over here, and then we can move to the meshing part, and let's see where we encounter. We will do the setup also, and we'll run the simulation. So what I'm doing is, so first of all, I will just unshare this one. And what I will do is I will start from the scratch. I'll simply delete this one, and I will just say, so let's say our flow is going to enter from here, and it is going to leave from here. So we can see here, like there is no such outlet domain to stabilize the flow. Now we will take the suggestion from Ansys GPT also, like if this is the scenario, how we can rectify this. And based upon that, we will see how different suggestion it gives to us. So first of all, we'll simply just quickly extract the fluid volume, and I'll simply give the name selections also. So this is my outlet. I'll simply give outlet, and this is my inlet. Inlet underscore small. And let's say this is my inlet large. Simply I've given the name selections. I'll simply share the topology. Okay. Now I'll just quickly do the meshing part. Switch it to MM. So it will take around 2 to 5 minutes only, not more than that, for running this entire simulation, doing the meshing, and then running it for some few iterations, and then we'll see how the flow is performing, whether it is getting stabilized or not. If it is not getting stabilized, how we can do, if we encounter any reverse flow, how do we resolve that? So we'll simply import the geometry. We'll simply go with the by default mesh generation. We will not give any kind of local slicing, since it is for a demo purpose, and we don't want any sort of accuracy as if now. We are just concerned like how the flow is going to get stabilized. The mesh quality is around minimum orthogonality of 40.40. We'll switch to the solution. So once this is done, we will also take the help from the GPT, that is your Ansys GPT, and you can also can also access Ansys GPT from direct web UI as well, from the your Chrome browser or Internet Explorer. So that also I will showcase you. So let's say this is the geometry. I want to go with the simple heat transfer. Turn on the energy equation. Simply we will give the boundary conditions. Inlet will be inlet. 75 degree temperature is there. Apply close. And in the small one also, we will give some, let's say 30 meters per second and 100 degrees of centigrade. And we will simply initialize and run the simulation. This is just for the understanding point of view. So we can skip few of the conditions as well. I'll just so you can see I have just stopped. Reverse flow is increasing from 0.1, 0.3, 0.4, 0.7, 0.9, 1.1, 1.4. It might also increase to 50% or 70%. Now let's say you have run this for 1,000 iterations and your reverse flow is not reducing. So if it is under 10%, that is okay. It won't create that much of problem. But when you are working for any kind of MRF simulations or the blower simulations or pump kind of simulation, turbo machinery, so at that point of time, if your outlet is too close to your recirculation zones or the blower out domain, the MRF region, you will be seeing a lot of instabilities in the flow. So at that point of time, how do we rectify this kind of challenges, right? So let's say right now it is 1.4%. It is under the good to go conditions, but we are concerned like we don't want any sort of reverse flow. So either you run it about more iterations or either you what you can do is, so let's take the suggestion from the GPT. So here is your engineering copilot, and you can see it is getting loaded. Once it is open, we will ask the Answers GPT like we are facing reverse flow issue. You can go to the GPT part, fluids domain. You can ask your question here. I am facing reversed flow in simple in I am facing reverse flow mixing T simulation. How to resolve the reverse flow? And I'll simply press enter. So it will say it will give the feedback based upon the questions you have asked. Reverse flow in mixing tea typically occurs when the local pressure difference across the boundary causes flow direction to change, and it will give the resource from where it is taking. And similar way, it will also case in cases where persistent cause of convergence problem, especially in mixing plane. So it will give you based upon the questions you are asking. So other way is also there. You can directly log into this GPT basically. So for this, you can open Ansys GPT. So from here, you can see ansysgpt.ansys.com is the website from where you can access the Ansys GPT. So here I will say I am observing the reverse flow and mixing T simulation. So when you come to this website, you will get a detailed version of the answers basically. So it is the same itself, but here you will, if you see on the left hand side, this is the same which we are getting in the tool also. But here, if you see, you will get different amount of resources. So this is basically your manuals. This is the, if you see number 6, this is the article. So here are the totally 10 resources from where it is giving us the answers. What are the, what causes the reverse flow in the mixing tree simulation, troubleshooting and resolving boundary type adjustment, you can see species composition. If you are going with species composition and everything, and additional consideration also it is showcasing us, along with the different materials which it is suggesting. So let's say you are already having one of the solutions in your mind. Let's say if what if I extend the outlet domain, you're not sure whether this will help or not, so you can ask here also, what if I extend the outlet domain? So you can use this GPT in this sense also. So it will give you the relevant answer based upon the requirement. So we can also see extending the domain in your mixing tree can help mitigate reverse flow and improve solution stability, especially in the boundary condition is current placed near the regions or recirculation of complex flow problems. So let's say it is suggesting us, if we extend the domain, the reverse flow will eliminate completely based upon that. So how we can verify this also? It is also a verified tool. So what we will do is, we have seen somewhere around 11 iterations, we have seen there is a reverse flow of zero point 0.4 or 0.8%, 1.4 percentage. Now just simply I'll close this one. I'll extend the domain with certain length, and then we'll see how, whether it is initially showing any kind of sort of reverse flow or not. So this is how we can also verify the GPT based suggestions. We'll come back to the geometry once again. I'll simply share and pull this. This volume directly. It's 250 mm. Let's say 100 mm. If it seems less, we can go with 150 mm or 200 mm. Okay. Now we can extract the fluid volume, or you can directly pull this volume as well. And there is no problem in that also. I generally used to prefer going volume extraction again if there are any sort of joints available. Simply we will do this. We can quickly give the name selections. This is your outlet. This is your inlet. Quickly, we'll do the share topology, and then and we'll update the mesh directly. So this will help you out where you are seeing significant amount of reverse flows, or when you are dealing with any sort of turbulent turbomachinery kind of problem, especially where there are impellers or the rotary equipments are involved, whether it's your pump, whether it's your blower. So there you generally face the issue of the reverse flow. So here there you can extend the domain. How do we extend the domain? That also you can ask to the GPT. Like how generally we can extend. General criteria is we generally extend the domain based upon the diameter. So 3 to 5x of diameter we extend the outlet domain. So let's import this again. Quickly do the meshing part. We just have to update it. No parameters has to begin. So any one of you or any using this Ansys GPT, or were aware of how we can use this GPT in our day-to-day work, or you are getting it or knowing it for the first time?
Shubham, there are people who have questions on the GPT.
Okay, okay. So these questions are on the chat box.
Yes, they are on the chat box. So some questions are like on what version and above is it available to use?
Okay, okay. There are a lot of questions, I think. Uh,
Mm. It's
so
from this R.
this is available from 25 R1 onwards. I think you might be using a previous version basically, so that might be a problem. In Workbench Mechanical, would I also work similar? Yes, in Mechanical also it would be the similar way only to use this Ansys GPT and the engineering Copilot. In Mechanical also you can find the tab learning and support tab similar over here, and from there you can also use it in the Mechanical also. So there is no restriction based upon the physics. So this we have
Sorry to interrupt, sir.
got
Sir,
the
is there any
yes.
limitation of license? Can we use this on student version also?
Student version, yes, I think you can use, but this is generally for the commercial use. So this feature is involved in the commercial license basically at no extra cost, but this is majorly in the commercial one. Student version also there will be there, but there is no such kind of restrictions to use it up. But the major thing is it is also only supporting in or above 2025 R1 version. If you are using the lower version before 25 R1, I think this will not be there in that versions. So this has been introduced in 2025. So I am using 2025 R2, and in that it is available. I hope your query is clear, right?
Yeah, thank you so much, sir.
Okay, welcome. So now simply we can take the same boundary conditions. We will not change it up, and we will see is the reverse flow is resolved or not. So you can see the reverse flow is resolved. Additionally, we will in the first few iterations only you can see there is no reverse flow at all. So this is how you can take the suggestions from the Ansys GPT if you are getting stuck at any point of time. So for the smaller queries or even for the training materials, you can visit this Ansys GPT. So let's say I have done this, resolved this, or let's say you might be getting when you are working on the complex physics or you mismatch the boundary conditions basically. So you might get sometimes the error of floating point exceptions, right? If you are aware of. So if you're getting any sort of that error, you can simply write, I am getting floating point exception error. So GPT will help you to rectify these errors. It will showcase you few of the suggestions. You can try it out. You can check it step by step. What could be the possible cause of this floating point exception? Generally, numerical instability is there. So setup wise, that is the major thing. Apart from that, your hardware can also restrict if the hardware is low. So you can see floating point exception, common causes of floating point exception, poor mesh resolution, improper boundary condition placement, linear solver failure, insufficient solver memory allocation. So based upon here, you can choose the appropriate step which you feel like you are confident your boundary condition is not a heavy problem. You can check whether when you are running the solution, your RAM is shooting up, your CPU is at full usage or not. So this is how you can take the help from the Ansys GPT to get and resolve your problems step by step in an easy way. So this is how you can use. Apart from this, also you can use like you are interested to learn something advanced or something new topic. Let's say you are interested to learn the multi-phase simulation. So what you can do is you can go over here. ALH access is now directly being linked over here. So one thing is you can directly go on the ALH. Otherwise, what you can do is you're not so sure like which multi-phase or which topic would be available where. You can write it over here in the AIS Answers innovation space, or you can use type the same in the GPT. So let's say I want to search the AIS, right? And learning, I want to go in the learning phase, or you can select over here fluids, or let's say external aerodynamics. So whatever relevant available to the term external aerodynamics, it will come over here. So external aerodynamics of a supersonic rocket, aerodynamics of a solar car, getting started with Ansys Fluent multi-GPU solver, which will be having external aerodynamics, introduction to aerodynamics 10, aerodynamics of phase car. So this is how you can use. So let's say I want to go with the supersonic rocket. I can simply click it over here and it will open you the Ansys innovation space over here in the new tab. And from here, you can take the lessons. You can enroll from here. You can take the entire lessons from here. You can also get the simulation files. You can download it from here, the simulation files, and you can follow the steps. You can follow the material lessons. You can refer the YouTube videos, and then you can go on the next lesson how to prepare the geometry for that meshing interface, how to do the meshing simulation setup, post processing, and then parametric study. How do we do the parametric study for the external aerodynamics? And if you want to take the quiz, you can also take the practice quiz also. And this is how you can perform any kind of learning courses through this same. This you can also get it from Ansys GPT as well. So from GPT also you can take this. So let's say you are in GPT, you want some tutorial. So let's say you are working on some radiation model or something like that. So you want some tutorials over that, or you are, let's take an example of mixing tea only. So mixing tea CFD simulation tutorials. So all the mixing tea related simulation tutorials, it will share you the link over here. If there are any courses, it will take you to the courses. There are any Ansys videos available on the YouTube for the same, it will take you over there. So if you see step-by-step guide mixing tea CFD simulations, so project startup, it will see here there's a course of the mixing tea. So you can simply click it over here and it will redirect you to the course. So this course is placed on the Learning Hub, Ansys Learning Hub. So you can log in and go from the Learning Hub. In similar way, let's say these are some videos which are there in the YouTube channels for Ansys. So you can see over here. So these are related to the meshing of the same simulation work. This is also again a course. So let's say this is a simple mixing tree. You want to see mixing tank. So you can search the mixing tank CFD simulation. So all the materials related to it, it will showcase over here. On the left hand side, you can see the list of resources. So this book indicates the course from that is your PDF. This indicates the YouTube link. Okay, this has been now refreshed. So for mixing times also, it will showcase you step-by-step mixing time procedure, boundary conditions, like you can see over here. how do we provide the rotation and all, set the rotation direction to match the geometries, multi-phase if it is required, multi-phase setups, no slip wall condition, no slip other slipping boundaries. So these are the different ways you can use this GPT in your day-to-day life. You can also get the best practice for mesh refinement. So when it comes to any of the mixing tank simulation, there will be an agitator. So once your agitator is rotating, generally the MRF region mesh requirement is a fine requirement. So it has also suggested mesh refinement techniques over here. Then boundary condition setup tips it is giving, troubleshooting floating point exception, because in the same session we asked the GPT, I am facing the floating point exception, if you remember in the previously. So it is also keeping that in mind and giving you the answers, like you can also troubleshoot floating point exceptions. And here are some reference and tutorials available for the mixing tanks. So this is a rocket tutorial. So if you open it over here, from here, you will see the tutorial. Then you can see the sloshing or mixing, filling, mixing and sloshing. So whatever content available in the Ansys portal, wherever in the Ansys portal, entire portal, it will help you to give you the best possible results from there. So you can see this is tutorial for mixing tank, and it is also based for fluent rocky coupling. So you can see the entire tutorial with everything step-by-step process has been given over here. So we can refer this and we can do our simulation. So this is of whichever domain you are working in, whichever physics you are working in. If you face some sort of queries or errors during your simulation, this is a very handy tool placed inside your tool itself. As you can see, it is inside the tool only. And it's very easy to use also. So you can quickly perform any kind of, you can ask the questions, you can get the tutorials if it is available. You can use those tutorials for reference cases. You can, if you have any questions, you can post it in the forum also. You can add from here, start a new post. You can create the category. You can enter it. Let's say it is for the Ansys 3D design. So this is basically your discovery modeling or space claim. Enter the title of the discussion. You enter the details over here. If you have any screenshots or working files or any sort of URL you want to enter, you can enter and you can post it over here. So it will get posted in the Ansys forum. So Ansys users, whoever will go through that, will suggest you the answers. Or you can have an open discussion. Basically, it's sort of open discussion platform. So this access is also there. And then again, this GPT is already there. So for your 24/7 as your virtual assistant. So this is how you can use the engineering Copilot and Ansys GPTs. So any questions up till now?
I think there are two questions in chat box, please.
Okay.
And Shivam, earlier the Ansys GPT was outside of the workbench, right? So we would
Correct.
have to access it. Now it is inside the workbench. For any of the
Right.
applications, we can just pick it up and use. Okay.
Yes. Now it is inside the workbench. Since this Fluent I have launched inside the workbench only. So this will be inside your Fluent. In similar way, let's say if you also want it for the discovery modeling. So in discovery also it is there. Discovery modeling simulation. So it is available both in standalone as well as for your workbench also. Earlier it was outside, but now it has been integrated inside this only. In 2025 R2, you will find a section learning and support. From there only you can use this Ansys Engineering Copilot inside the tool. And also, if you want to go outside the tool in the open browser, that option is also available. So this is that option, which is available in the browser menu. So both the options are available. I hope I cleared your doubt.
Yes. Yes.
Internet was Ansys GPT license, right? Or is there so there is basically that this license is free. You have to just register it, and also if you are having this ALX license, at your end, that would be more helpful for you. So you can also go through the content on ALH, which is available. Otherwise, also without ALH, also you will get the open source. Open sources in YouTube links and the tutorials which are there in the manuals and all that you can access. Can it be used in, for instance, in harmonic model? And yes, you can use in any of the analysis. That is not a restriction. So let's say you are doing a model analysis or harmonic analysis and you are facing some sort of error, or you are saying like this is there is some challenge, or you are getting some sort of errors while performing the simulation. So that error also you can mention in the Ansys GPT, and that will help you to understand like why this error is happening. Sometimes what happens is when we do a bigger CFD simulation or mechanical simulation, and we our system don't have that much of RAM or memories, right? There are ways the system gets crashed, and we are unaware like why the fluent got crashed or mechanical got crashed, right? So in the log files we will be getting an error. So that error we can copy paste, and we can ask the GPT also to confirm whether it is a boundary condition error or how what kind of error it is. So that will also give you an insight in those kind of scenarios also. So Navya, I think I hope that clarifies your doubt.
Shubham, will it also give suggestions for parametric, you know, options? If we ask what parameters to change, how to set up parameters, will it give some options for that?
Yes, it will give you like how you can set up the parameters. So let's ask over here only how to do a parametric study. It will directly not give like these are the parameters you change and you will see a drastic result change, right? It can give you a suggestion. Based upon, then we have to also think for our engineering senses, and keeping that mind, if it seems like this will work for my particular solution, then we can go ahead for it. Because see, this is something which is a generic GPT, right? And our problem on which we might be working would be very specified problem. So then we have to correlate also whether this is actually this suggestion will actually help me or not. So that correlation is also important in that case. So since I have asked for the parametric studies, it is suggesting me options for the mixing tank itself. But you can see initialize the parametric study, set up design points, degree of experiments. And then you can also, it is also suggesting automate the simulation runs, analyze the results, mixing performance, mesh morphing, and if you are into the advanced things also, that also you can do. You can also in similar way ask what parameters can I perform. So for that, I think you have to give like what are the parameters you are opting for. So that if you give it to the GPT, it will give you a better answer. If you want some specific results, then you have to give some specific answers. We have to tell the GPT in a specific manner. Otherwise, what it will do is if you don't specify in depth, it will give you a generic view. But if you specify each and everything, it will try to fetch the exactly that data. So it's all based upon the input what we give to the GPT. Yes, that will also help you for the convergence solution. If you are facing some divergence issue, that will also help you to resolve the divergence. See, let's say I am facing divergence issue in CFD simulation. So it will give you an overall steps. It will also give you what could be the possible causes of the divergence, what troubleshoot you can use to rectify the or resolve the divergence. And see, as discussed, common divergence common causes of the divergence, poor mesh quality, improper posted boundary condition, solver parameter setting, physical model solution, and best practices for stable convergence. It will also give you along with the data. So this you see problems with convergence. So all the list of sources listed over here, you can click from here also. You can see troubleshooting cases. So based upon your requirement, you can go through the materials and you can find the relevant steps to resolve the direct divergence issue. So this can also be done. So once you start using it, you will feel the capabilities of it, and you can see how it helps you to rectify your errors and challenges quickly. Whether it's steady state, whether it's transient, doesn't matter. It will give you a better option answers when you ask it with. So now coming towards, so this was it for the engineering copilot. Now we will be moving towards the overview of SameAI, how SameAI is going to help you for running the simulations. So moving towards the SameAI part. So this is SimAI is basically your artificial intelligence for the simulation world. So basically Ansys AI consists of three parts. Ansys AI Plus, that is our upcoming part, which will be there as an add-ons. Ansys SimAI we will talk about. I will give you an overview now. And Ansys GPT and Copilot we have already discussed, and I have also showcased you a small demo, a simple demo, how we can take the suggestions from the GPT and perform our simulation with the result solutions. So when it comes to the same AI, that is basically speeding the simulation with the help of AI. So basically three steps are involved in it. So first of all, first step is to upload your past simulation data. Then you have to train the AI model as per your requirement, and then we will predict the results in seconds and or minutes basically. So this involves basically the three-step process: upload, train, and predict. I will also show you the brief workflow and a demo of the SimAI as well. I have got the few videos so which will help you to understand the entire working demo of the SimAI. So basically SimAI is the new cloud-based AI platform for simulations, which will help you to speed up the simulation. But doesn't matter whether it is of which physics, it is a physics neutral. So basically you can perform any kind of physics simulations, whether it's structure, fluids, optics, electromagnetics. That does not impact on this. It can work across all the industry segments, whether you are in the semiconductor, whether you are in the electrical domain, whether you are motor manufacturer, whether you are into the automotive or EV industries, whether you are in the aerospace. This will help you out with this. Any sort of 3D simulation data, it will help. So let's say you are training your AI model for the simulation, but your previous runs which you have done is from some another tool. It's not from the Ansys. So that also it can help to get trained your model. So it is not only restricted to the Ansys itself. So once you give this previous data, you train your AI model in such a way, then you get the expected results in minutes and seconds. So SimAI basically you have to upload your data. When it comes to the uploading data, we all know simulation data is so much size. It can be somewhere from GB to 1 GB to 20, 25, 30 GBs also. So uploading speed is 1 minute per GB. So it will not take that much amount of time. For training your AI models, it will take somewhere around 2 days. So basically for 48 hours, it will take to train your particular AI model, and then prediction, the results of the new design will take somewhere around few seconds to few minutes. So that is the thing. So when it comes to the training your AI model, so that is something like if you want to perform the aerodynamic simulation, we have to train our AI model for the external aerodynamic simulation. If you have to do for the battery simulation, we are training our AI model with the battery simulation with some previous simulation datas which we have already did in Ansys or other tool. So it is not restricted to any sort of physics. It is a physics neutral. So you can use it in fluids, fluids, that is your CFD part, you can use for structures, you can use for mechanical LS dyna, you can use it for electronics, you can use it for optics. So all the options are available for this same AI. Now coming towards the workflow, we'll see how the workflow helps us for the same AI part. So basically, first of all, we have to prepare, then explore, then validate. So what comes in prepare is data. So data is something which is your existing simulation data. So let's say you have been working on this aerodynamic kind of analysis for past 1 year, or you have 20 or 30 different aerodynamic analysis data that you can upload it. Then you can train your sim AI model, and then based upon the model which you have trained, you can explore various design parameters, various simulations, and then you can validate the one which is more compatible or more relevant to your simulation, and then you can validate that with full fidelity simulation. So this is one of the examples of the workflow for the sim AI basically. So upload, train, and predict. These are the three steps for the sim AI. So we will upload the past simulation results. We will train your AI model, whether it's for the external aerodynamics or whichever physics you are wanting to go with the simulation. And then you can see the 20 hours of simulation time is only taking 2 minutes to predict the same behavior. And when it comes to the external aerodynamics kind of problem. Same thing, you can go with the crash analysis or bumper analysis. Then this is the cooling analysis, 1 hours on 64 course, and it's taking only a few minutes when we go with the same AI. The only thing is we have to train our model, and that will require somewhere around 2 to 3 days of time. Once the model has been trained, you will not take that amount of time to further predict the results basically. So this is the demonstration for the same AI, which indicates how the tool is and what is the UI of the tool. So we'll be seeing how the predictions we are taking. So this is the entire UI. On the left hand side, you can see these are the projects and the workspaces. Here we will be uploading our existing data, simulation data. Simple drag and drop. You can simply drag and drop the surface files. Basically, this is the surface file which we are uploading. Then we will be running the prediction. So in similar way, if you want to upload the data, the train data, so that also is there. On the right hand side, you can see we are generating the surface for the same. And then once we move to forward, this is the run, because this was already model was trained, and uh, trained AI version has been created. But if you want to build the model, so this is the step to building the model, how we can build the model. So in this step, we will create a new project. We'll give the project name. We will train the model accordingly. We will add the existing data or add the new data. Right, simply we will all the past simulations what we have done, we can simply drag and drop, and it will get uploaded very fast quickly. So the speed is 1 minute per GB, and then we have to configure the model to analyze, give the boundary conditions like what we are expecting. So in this case, you can see we have selected the required parameters. So this is how we will configure the model and select the variable of our interest, and then we will train this model accordingly. And we'll once you do this, you can see we have to define the volume. From here, you can define the volume. This is for ship hull design. And based upon this, we will give build the model, and then we will run for the prediction. So these are just few of the quantified case studies which already developed. This is your bumper impact test, crane hook test for mechanical engineering. So now let me take you to the fluids case studies. So these are the few various studies which we also saw. So basically, the flu it was earlier done in the Fluent, and for Fluent calculation, it took around 5 hours on 200 cores, but SimAI predicted in approximately 30 seconds. So this is how you can accelerate your simulation time and reduce the uh, time which is there to perform the entire simulations from the scratch. So this is how uh, it will help you to accelerate the ongoing simulations using the various AI tools. Similar way, battery thermal management conceptual design is there. So this was also done with the Fluent and the same AI basically. So this is for the various cooling designs and battery life cycle. This is for the power inverter cooling. So you can see how on the left hand side bottom, if you right hand side bottom, if you see the Fluent took around 1 hour on 64 cores, but SimAI is nearly taking about 30 seconds. So this is how you can reduce the development and the simulation time using the SimAI. You can also use this for the centrifugal pump designs or any kind of pump designs or turbo machinery part. You can also use this for the heat exchanger. So when you see the simulation with the Fluent or CST simulation discovery simulations, it's somewhere taking around 2 hours. But when it comes to the same AI, it's only taking 20 seconds, and you can see the outlet temperature with the detailed CST study is somewhere around 57.3 degrees. But what CMAI is producing 57.4. So near about very close to the existing results, right? But if you see the simulation time, it only took 20 seconds to predict. But when it goes with the Fluent or any other solver, it will take more amount of time to plot this kind of filling criteria or animation, basically. Same goes with the solid suspension in the state tanks, mixing tanks. When it comes to the mixing tank simulation or state tank simulation, Fluent takes a good amount of time to run the along with the multi-phase and everything. It takes around 12 hours on 64 cores. Same thing, around 30 seconds with the semi prediction, whether it's sparging gas in bioreactors. So this can also be done. This is the hull design. So basically, it helps you to predict the simulations. So CFD calculation took 4 hours on 30 cores. It took around a minute to do the same prediction in same AI. So this is automatic workflow for mixing. So this is how we defined or train the model. So this is how the model it will be and will get the prediction over here. So that is basically your post processing for the simulation. Same way for FSI, this is for the read valve. So the intention to showcase you all these case studies is like these are the various areas where SimAI has already been used and validated against that. Again, one of the examples for straight time design. So same ways we can go with the structure. So this is the bumper impact performance. So bumper impact initially was done in LS Dyna. Now you can see the same sort of behavior with the same AI predictions. Same way for the jet engine bracket. So this is also you can see this was done with the OptiSlang and discovery for this optimization point of view. And the same AI has also done the same thing. So this is the first one is for the discovery one and second one is from the same AI. And this is even you can see the displacement over here. This is for the one mistresses and for the first the this you can see the displacement. And this is the comparatively for the displacement versus the one mistresses. So this is how uh, the sim AI will help you out in your day-to-day work or to accelerate the existing simulation. And this another study for the crane hook design. So that also, if you see mechanical 20 minutes on 4 cores, but if you see with the same AI, it is somewhere around a minute. It took only around 50 seconds to give the similar kind of results. So difference, if you can see from the mechanical and the sim AI, the percent difference in terms of percentage is somewhere around 0.32 or zero point 0.5 basically. So this is also very close to the accuracy. It's not like that it is performing the simulation in this kind. The prediction is way too fast. it would be not that much accurate. But when we compare it to the mechanical or the CFD simulation, you can see a difference between prediction and the mechanical simulation is almost same. Maybe around 1% deviation might be there. So this is one of the testimonials from the Reynolds group where they are like extensively using SimAI basically for their day-to-day work. And yeah, that was it from my end for this webinar. If you have any questions, you can ask. I think if you want to get the slides of the session, we can connect one-on-one. We can discuss and then maybe I can share it with you. For that, I am just dropping my mail ID. So if you want to go in depth and you want to see like what are the different ways, or what are the other capabilities which we can do, that for that we can have a separate session purely based upon your requirement in which we can understand your requirement and we can showcase you. Additional license is needed. Yeah, for SimAI, there is an additional license which is required. So we need to upload .out files or result files for for CFX. Generally, we have to upload the results file, but still, I can check it up for the CFX part, and I will. We can get connected, and I can let you know in depth or like what exactly are the files for CFX which is required. This mechanism which generally has 300 GB of file. Is it possible also? What type of file do we need to upload? Is that if you have mentioned? We need to upload the result files basically to train the model. So I have dropped my email. We can connect and we can have a further discussion to this, Akhilesh ji. So Akhilesh ji, we can connect with Mr. Anil. He is also there. So he is taking care of the mechanical part. So for mechanical, you can drop me a mail. I will make you connect with him so that we can discuss the mechanical part with him for the detailed discussion. If you want, I can drop his mail ID also. You can directly mail him. We can plan a separate session based upon the requirements and then we can take forward from there.
I have a question here, Shubham. Is this all connected to the MBSE as well?
Sorry?
Is Sim AI also connected to MBSE, Model-Based System Engineering?
Model-based system engineering, what you want to exactly connect for that? Because see, there are upcoming AI add-ons which will be there for this, but still need to check it up whether what you are exactly looking is there or not.
Let's say you are working on multi-physics problems, right? So if you have
Mhm.
parameters or values that needs to be managed, so we don't know the initial range. So we will give some estimations and then say, okay, for these initial numbers, can you give me a realistic starting point where I can start the realistic design? So for these
Mhm.
kinds of applications, can we look at using Sim AI, or do we look at having each of the simulations uh, AI generation done and then club it with the other simulations to then say, okay, at a system level, this is what is a possibility.
So this is not which we can directly do with the SimAI part as if now. So for this, what I understand is you are not clear with the outcome points what you want, right? You wanted to know like initial points and the maximum points in between the range you want to perform the
Correct.
simulation, right? So for
Yes,
that,
yes.
see, because this simulation works upon certain outcomes or certain inputs, if you are not clear about that, even if you do the simulation, the system will get you the results, right? But then you have to take that call whether this is in an acceptable range or not. that validation, then you have to do it at your end, like with some theoretical data or numerical calculations, or there might be some correlation, basically what I mean to say. If you have that correlations, then we can definitely do this with this. Otherwise, what we have to do, we have to perform the first CFD or FEA analysis, and then we can, once we have the better correlation, then we can switch to the semi.
I see. Okay. Work needs to be done.
Yes, you can mail to anil.cat@arkinfo.in for more clarity on the mechanical part. So we will plan a separate session, 30-minute session, and we can discuss your problem statement, and based upon that, we can provide you some more clarity and solutions, which solution will exactly work for your part. So yes, you can drop a mail to him, or you can drop a mail to me also. That is not a problem.
So Shubham, when we upload the result files, where are the result files getting stored? Is it on the cloud or where does it
Yeah,
usually
yeah,
get stored?
that's on the cloud. It is exactly based upon the cloud system, the SIM-AI.
I
So
see. Okay.
recently, SIM-AI Pro has also been launched. It will be coming in this 126 version. But that is still we need to check whether the capabilities are of cloud versions or not. But there is certainly plan of getting it on the desktop version, like we have the other tools. That is your CFD or mechanical part. So
Right.
that tool
So
is
that
also going do. Sorry.
Shubham, am I audible?
Yes, you are audible.
Yes, yes. Sir, I want to ask that whether we can reduce the time required for the training of the data. SIMI.
See, that actually again depends upon you how fast you see. Initially, it will take a bit of time, but once you get an overall idea, like how what are the parameters I need to train for my model. So next time it won't take that much amount of time. But initially, if you are going for the first time or the second time, it will take between 2 to 3 days to train your AI model. But that can be reduced based upon your reusability.
Okay, fine.
Hello. Hello.
Hello.
Yeah, am I
Yes.
audible? Yeah, you just said
Yes.
that the result file that we are giving the inputs that would be stored on the cloud. Okay, but
Mhm.
many companies are having the non-disclosure. How do you handle that non-disclosure agreement thing?
See,
Because confidentiality is obviously for each company it is there.
right. So this will be specific to your access only. And also in the near future, this Ansys is launching the desktop versions also. Like we have for this fluent and mechanical that will be installed on your system itself, so that version is also there. For that, the initial version has also already came, that is the sim AI Pro, which is the desktop based version, and further enhancement and the full capability is going to be there in the near future itself, so
Okay,
that
down the line,
problem
how
will
much
also
time
be,
we can expect this version?
I think maybe 2026 R2 version, maybe that we
Okay,
also have to check with the developers team from the Ansys.
okay. Thank you.
Yeah, welcome. So I hope everyone questions have been cleared, or do you have still any questions? Even if you face anything, or if you want to get in touch after this webinar also, like if you feel you want to know further more for the CMAI, I have dropped two mail IDs. You can ping on any one of them, and we will be happy to assist you further.